videos are over section 6.5, rational functions and rational equations. A rational function, function f is a rational function if f of x equals p of x over q of x, where p and q are polynomials and q of x does not equal 0, since of course we cannot have a 0 in the denominator. We're going to talk about some aspects of the graphs of these functions. A vertical asymptote often occurs in the graph of a rational function. It's at those values of x where q of x equals 0 and p of x does not equal 0. That is the values where the denominator equals 0 but the numerator does not. What happens is those end up, that's an x and y axis. Maybe we have a vertical line here where the graph might look like that, and like that, comes close to this asymptote but does not cross it. We also, in some of our graphs of rational functions, we will have a horizontal asymptote. So the y value approaches an a as x goes to positive or negative infinity. The graph is a horizontal asymptote at y equals a. Now, we'll discuss various ways to find that horizontal asymptote. So a horizontal asymptote, if we have this function and we have a polynomial over a polynomial where our first terms do not equal 0. If the degree of the numerator is smaller than the degree of the denominator, then we have a horizontal asymptote at y equals 0, the x-axis. If the powers, the degrees of the numerator and denominator polynomial are both equal, then we have a horizontal asymptote at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. It becomes that y equals that fraction if it stays a fraction. However, if the degree of the leading of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. At that time, we actually have what's called a slant asymptote. Now let's do some practice of finding the various asymptotes. We're going to find a vertical and horizontal asymptote and then sketch a graph. First, finding the vertical asymptote. We have the denominator. We just take the denominator of the fraction and have it equal 0. Well, in this case then, x minus 3 would equal 0. So x equals 3 becomes my vertical asymptote. So, doing our traditional numbers, we'll have x equals 3 as a vertical asymptote. For the horizontal asymptote, the degree of the numerator is 1, and the degree of the denominator, if I multiply this out, would have an x squared minus 6x plus 9, so it's 2. The degree of the numerator is lower than the degree of the denominator, so it's automatically a horizontal asymptote at y equals 0, or the x-axis. This becomes the asymptote. Hard to see there. So what is x equals 3, and this was at y equals 0. Now, drawing this graph, and of course we can do that on our graphing calculator. I've kind of looked this up to see what happens, and what happens with this graph is it looks similar to this. You'll see let's practice finding vertical and horizontal asymptotes. To find the vertical asymptote, we let the denominator of the fraction equal 0. Well, that means x minus 3 will equal 0. It might turn out that x equals 3 then is my vertical asymptote. And so, numbering the graph this way, we will have a vertical asymptote here at x equals 3. X equals 3. Now, for the horizontal asymptote, well, the degree of the numerator is 1, and the degree of the denominator is 2, because we multiplied this out, we'd end up with x squared minus 6x plus 9. So 1 is less than 2, and so we have a horizontal asymptote at y equals 0, or the x-axis. Y equals 0, that's my asymptote. Now, of course, you may graph this on your graphing calculator. What happens here as we would do this graph would end up similar to, it goes, as x goes to infinity, goes to 0, and this vertical asymptote comes closer but never touches there. And the same thing happens on the other side. Now, this is not an exact representation. This was a quick sketch, and of course you may do it on your graphing calculator and see a maybe better representation, except the asymptotes will not be drawn in. Here's one more rational function for let's find the asymptotes. I believe again we can number by ones. The vertical asymptote, the denominator equal to 0. So I end up with 5x equals 3, and x equals 3/5 is my vertical asymptote. So that's going to be approximately here. Then, for my horizontal asymptote here, n and m, the degree of both is the same, so it's really the ratio of the leading coefficients. Y equals 2/5. Just this fraction right here is my horizontal asymptote. So that's going to be approximately here, trying to get quite halfway. And again, I looked up these graphs, and it has a shape similar to out there, and this one comes close again to the dotted lines from this lower corner. Again, I encourage you to grab your graphing calculator and graph this. Remember, parentheses around the numerator, parentheses around the denominator.